just to reiterate what I said for the purpose of video. So this is for problem 1. You start here, okay, and you just do it for R instead of V. This is the definition of dot product. You start here and you differentiate both sides. When you differentiate both sides, this is what you need to know. The differentiation of a dot product is this: A dotted with B dot plus B dotted with A dot dotted with B. Now I have already warned you guys. If you do this, it's wrong. You'll not get anything. You understand why? This means scalars. If you do this, you'll not get any points. Understand why? This operation itself is not defined. A vector cannot be multiplied by a vector. A vector can be multiplied by a scalar. This is okay. Okay? You can multiply a vector by scalar, but vector multiplied by another vector, it's not defined. If you do this, you won't get points. So make sure that dot is where it has to be, and it is vector. Whenever you do dot product and cross product are defined only for vectors. Jeremiah? Cell phones? Please no cell phones. Okay. Unless you are looking at the assignment itself. Alright? So keep this in mind. I think many of you will probably have forgotten about this. The other thing is, you may use this at a later stage, but
Can I step out to call somebody that's supposed to be here?
sure. This is the definition of, or the derivative of cross product. Okay. So look at how this is different from. This is how you remember this. What is this? How do you define if there are two quantities, scalar quantities? The definition is A, B dot, right, plus B, A dot, right? This is also equal to A cross B dot minus B cross A dot. Okay, so you can look at the similarities here. If you do it like this, A B dot plus B A dot. This is how you remember your product group. Most of you.
Yes.
You can change this, but when you take a cross product, you cannot just change that. If I change this sequence, it becomes plus. So this is what you need to remember. So this has got nothing. This is just a product group. This is your dot product.
So you just showed at the bottom. Okay.
Right.
Okay.
You want to relate it to your traditional dot product. Okay. Because this is anti-commutative, dot product is anti-commutative, this is what you get.
Wait 1 second. So the subtraction part. This must have happened when I stepped out. The subtraction part. What were you saying about that part?
Because it is anti-commutative. Anti or commutative. You understand what commutative is?
Okay. So you're saying when the V and the A switch.
If you go, if this switches, only then it becomes plus.
Okay.
Okay. So the second one is derivative, right? Taking derivative of a quantity. Or something like, what is it? It's
R equals cosine squared theta.
right.
Sine phi.
So this. So if you have something like this, what you need to understand is here. This is f of g of h of theta. You understand why this is so? It's a chain rule. Theta itself is this. Cosine theta is g of h of theta. Cosine square is f of g of h of theta. Right? If you take the derivative of this, if you take the complete derivative of this, dr over dt, it will be what? It will be first f dot, right? F prime. So if you take, this is your r, dr by dt is f prime, correct? G prime, h prime. That is your chain rule. So accordingly, what you will get is dr by dt is equal to 2 cosine theta, right? That is this f prime. G prime is minus sine theta, and h prime is d theta by dt. Okay, and this is what I have told you here is you can say d theta by. You can use this notation. Everybody understands what a notation is?
I don't know that notation.
You understand what a notation means? Anybody has difficulty understanding the English meaning of notation?
It's a representation.
Representation. So this is the notation. So this is d theta by dt can be expressed as theta dot. Right? Theta, any variable dot is generally a time variable. That's, you don't use as theta dot. Got it? So this is not the norm. This is the norm.
The what?
This is the norm. Any derivative with respect to time, you use that theta dot. Theta dot is time derivative. If it is derivative with respect to some other variable, for example, if this was pressure, you cannot just do theta dot. You just stick with d theta by dt.
You just leave it like that.
Huh?
You just leave it like that. Like if it's written into pressure, you don't put it equal to.
So what does this theta mean? This
Time.
dot mean
With respect to time.
with respect to time?
But this here is with respect to pressure.
No, where is the respect to pressure? You just see if this is not acceptable. We don't do pressure here, but if you are required to do pressure, for example, if you are dealing with space, you have to do pressure at some point. right? So that time you don't use theta dot for that. It is not a general derivative. It's a derivative with respect to time. Got it? So you see, whenever I use theta dot, it's always with respect to time. Okay? And things can change. They need not change just with respect to time. They can change with something else as well. They can change with pressure. They can change with temperature. Right? So this is your hint for doing second one. This is how you take a derivative. Okay? So you look at the complete product and make sure you apply all of this, and there is a product rule application as well there. The fortunate thing about this is not a vector. This is just a. Go to the third one.
That's when you give the vector A, B, and C, and you say
Right.
all the different.
Okay. So that's actually pretty simple. I just want to see if you're given something like this. Okay. When you're given something like this, the first thing you should understand is these vectors A and B. This is what you should visualize. This is your I, J, and K. This is the basis in which let's say your vector A is here, okay, and vector B is here. These both are coordinatized in this frame. Okay, you're seeing it in this frame. These two vectors. It's like you're observing two cars speed standing at one position, that is this position, and your reference is this for both of them. So this IJK means if you components, right? This will have components XYZ, XYZ component or IJK components. So AX is the component in this direction, AY is component in this direction, and AZ is component in K direction. Okay? So when you do A dotted with B, the process is do AX I plus AY J plus AZ K, okay. And again BX I BZ BY K J B Z. Okay. You actually do, this is a dot here. Okay, you do dot of this, dot of this, dot of this. Then you do dot of this, dot of this, dot of this. Then you do dot of this, dot of this.
And then when you do the dot of that, it'll be like an IJ.
Right. So what you do, I'll just show you for AX. Okay. So you have AX. This is the scalar part, right? AX into BX. I dotted with I plus AX into BY. I dotted with J plus AX into BZ, right? I dotted with K. Now what happens here? What is I dotted with I?
1.
Why is I dotted with I 1?
Because it's a
It's
rule.
not
It's a
What
rule.
the world is the cosine
Orthogonal.
theta, cosine J, the angle is 0 is cosine J.
But
Yeah.
why is I into I 1?
Because
You it's really I square, right? By this definition it is this.
Yeah.
Why is I square 1?
Because the
because they're the
threshold.
same plane.
Wait, that's the thing about an imaginary number.
Why is I square 1?
I thought it had something, because the reason, I thought it had to do with the fact they were in the same plane, since when they're not in the same plane, that's what that,
What?
that angle.
Look, what does the cap mean?
It's a unit.
Unit vector means the magnitude is 1. If this was not there, I cannot write that as 1. Okay, that is what it means. This means it's a unit vector. The magnitude is 1. That's why this I square means 1 into 1. Okay, got it? So this is AX BX. This is 1. Why? What is this?
0.
Why is it 0?
Because it's orthogonal and the cosine of the 90-degree angle is 0.
Cosine of what angle?
A 90-degree angle is 0.
What is that angle?
That angle is 90.
Huh?
That angle
I
between
and
I and
J.
J is angle
Right.
between I and J.
I and J, the angle between these is 90 degrees. Okay? So this is 0. This is also
0.
So there's no,
I dotted with J, I dotted with K is 0. Okay?
so the plane has, the two, unit vectors lying in the same plane, that in itself has nothing to do with that being 1.
No, not the plane. Only when the angle between them. If this was J, okay, then it wouldn't have been 0. See, this is a construct. You should understand what a construct is. This is all constructed such that conveniently these go to 0. Okay, so what you're going to get is you're going to get ax plus bx plus ay by plus az dz. You get it? And that is the reason I told you in the beginning, we can write vectors in this form, right? This is another form of writing the same vectors. So what is A dotted with B? It is just this multiplied by this, plus this multiplied by this, plus this multiplied by this. So this is the math behind that. Okay? And this is only true for orthogonal, when you coordinatize your system in a orthonormal basis. Again, what is orthonormal basis? Ortho means what?
90 degrees.
Ortho means 90. All the bases are ijk. The bases are ortho, means they are 90 degrees to each other. They are normal, means normal.
Normal means it's like directly perpendicular.
They're normalized. Normalized. They're 1. Their unit is 1. They have unit magnitude. These have unit magnitudes, right? They are cap. That cap means unit vectors. So orthonormal means they are 90 degrees and this thing is 1. The magnitude is 1. Okay. So use this to do part A and part B. You can actually do it in a very simple way. Part C is slightly more tricky. What is it? Part C? Tiffany?
It,
vector is to show that A cross B dot C cross D equals A dot C times B dot A minus A dot D times B dot
you need to just say
What's up?
Isn't it supposed to be BY?
Huh?
Isn't it supposed to be BY?
This one?
Yeah.
You're right, Quincy. You'll get a prize for it.
Bonus point, right?
Is it BY or what?
BY.
You sure?
Yeah.
No, it's A by B man. Sorry.
Wait, isn't that a B in the middle?
So what? No, this has to be AX, AY, AZ, right?
I thought it was B. A, B.
It's AY. It's just the vector A.
Very well, you're right then.
I have to take it back.
I think it was.
Quick question. So the reason why we dot the unit vectors and not the A and B is because those AX and BX become scalars.
They are scalars.
Wait,
Yeah.
what's your question?
Because we're doing
So if you look at this, the way it is written is, this is the magnitude in I direction. Those many units in I direction. You see, this has to be a number, that AX. So that's the reason you just multiply them, you don't dot. Got it?
Yes. You get it?
You're saying why did we not use the dot product once we got down here?
Yeah, because I thought we would do like AX dot BX,
Yeah.
but I realized why.
Okay. So C, part C, what you need to do is, part B is simple, you just have to validate this. Now, here is something I really want you guys to try. Try MATLAB. Okay. Really try to use MATLAB.
It's not level upstairs.
Hmm?
But it's only on one computer.
See if you can use it, especially if there are numbers. It's very easy to define a vector in numbers. So I would highly encourage you to do it. For example, if you do this, this is your MATLAB this thing. I'll tell you how to do a dot product. Okay, you define A equal to 1, 2, 3. You can do this in MATLAB, right?
Yeah.
Everybody can do this. B equal to 4, 5, 6. Right? When you do dot command A, comma B, this will output your dot product of A.
It's so
It's as really very simple. You can type this in MATLAB, right? You can very easily type this in MATLAB. You do cross of A, comma B, the output will be a cross product. Got it?
So for this one,
For this one, you may not be able to do MATLAB because there are symbols associated. You can actually do symbolic math, but it's a little more challenging than number math. Okay? You can do, see, computers are fundamentally designed to do arithmetic. They are actually not designed to do math. So you can program them to do math, but they are not really capable of doing math. You can force them to do math.
talking about this, the computer.
The computers, yeah. Any arithmetic, they'll do it for you. Without
This is not I need to see plus.
Computers are very stupid.
So the second one, the part C, what you need to do is, you have this, right? A cross B dotted with C cross D, right? What do you do with this?
Oh, you could turn them into a
can't
cross.
use that. It's too many. It's 4, so you can't use that.
What is the output of this? Output of this, is it a scalar or a vector?
What is
Scalar, dot,
Right. So you can say this, whatever is in parentheses, is another vector. You can say this. Can you call it E, vector E?
So you said E equal to that? Yes.
So this, what you can do is, you can write it as E dotted with C cross D. Right?
So
I'm just calling this, whatever is in parentheses, as another vector E.
Okay.
Nothing really complicated. Just another vector. A cross B is just another vector. Okay? Now what you do with this, you look at what you really need. You need A cross A dot C into B dot D. Okay?
So couldn't you say C cross D equal to something else?
You can do this like this. C dotted with B cross E. What I've done is I've just cyclically rotated. So this one has gone here. Cyclic rotation, you remember this?
Yeah.
Move one, this thing. This is moved here. Now you split this open.
Why rotating?
Huh?
Why rotating?
Because if you now split this, you understand what splitting is? If you put back A here, what A cross B,
Where it is.
where E is, it will become a triple block.
So that's your goal. You want this to be a triple product.
No, but the goal is mentioned
That's
there.
what
The goal is mentioned there. Your objective is to get rid of the cross. Right? How do you get rid of cross? You have to use back tab rule. So now, back tab. Right? If you substitute E here, you see it? You see the trick? Now you can use back tab rule for whatever is in the parentheses, whatever is in the square. So you're getting rid of your cross. And that's what ultimately will lead you to the answer. Okay? Alright, fourth one. What is the fourth one?
What's the?
It's a textbook thing. Maybe it's a textbook.
That's the one I believe about the coplanar.
Coplanar.
Yeah.
No, that is not coplanar. Coplanar is the last one, right?
No, I think that's this one. Remember,
Elena, you have.
it's like
Show me what that is.
C
Can you open it to that page and see what it is? It is page
53.
53.
I think that's the C page.
Oh, yes. So that is actually a very interesting problem. How are you going to do that? Have you looked at it?
Number 4.
Mm-hmm.
Maybe we need to get that drawn on the board.
So what you are given here is a simple figure, okay? So what you have C of n, okay? You have A. You have B. This is your vector. This is just defined as the U and vector.
What 2?
Oh, that's pretty tight. Oh, check it out.
You are given A, B, and C, right? And you are asked to figure out the scalar projection CAB on of C onto the plane AB. Okay. How do you go about doing this? Your question is find CAB. It is not this CAB. You realize that? What is the difference between this and that?
That's a vector.
That's a vector, that's not a vector.
Right. This is a vector, that is a scalar. You see?
Looking for the problem.
Looking for a problem?
See, take the magnitude. That's not the
No, you know only A, B, and C. A, B, C are known. So here is, I won't write this down. I'll just tell you, and you try to see if you can understand this. Can everybody see the figure? I think if you have a textbook, please open the textbook and see the figure. Whether the figure makes sense to you. Make sure the figure makes sense to you.
Is it similar to what it is right here? Alright. It makes sense to me.
But the figure in the textbook is much more.
Are y'all looking at it?
Is CAB on the same plane as AB?
Yes, that's a good point. Cliff.
See, say that one more time.
CAB is on the same plane as AB.
So that is what you really need to pay attention.
What?
Okay, and this is the plane of AB, this is the AB, it's on the same.
If you know A, B, C, okay, what can you find from here? See, the unknowns here are A, B, C are the knowns, okay. Unknowns are, this is unknown, this is unknown, and this is unknown. You get it? Guys, here. Okay. Just pay attention here. ABC is known. Unknowns are CAB, CN, UN. What will you try to find? What can be found rather? Knowing ABC. Can you find CN? Can you find CAB or can you find UN?
Will it be you?
How do you find UN?
I don't know, but
What does
You want
CAB?
the unit? That's a unit vector, right?
That's a unit vector.
Cross product of A and B.
Absolutely right.
cross product of A and B.
Cross product of A and B divided by the cross product of A and B.
Divided by the cross product?
See, cross product will give you a vector in that direction, but you want unit vector in that direction.
Oh, yeah.
So you divide by the magnitude. Got it? Everybody clear on that?
I got the numerator,
Alright, so
but the
cross.
denominator, you divide by what?
Divide by A and B, A cross B. See, if you want A cross B, will give you a vector which is perpendicular to A and B. It will not be unit vector.
Okay. Because the way, unless I wrote wrong on my paper, I got A cross B divided by A cross B.
Divided by magnitude of A cross B. You get it? Why it is magnitude? How do you make a vector unit vector?
Yeah.
You just take away the magnitude, you just have the vector.
Huh?
You take away the magnitude, you just have the vector.
You make a unit vector by dividing it by its
Magnitude. You divide the vector by its magnitude. Any vector, it's not just this. If you divide A by its magnitude, it becomes the unit vector in A direction. So you find un, okay? If you know un, you will know how to get the projection of C on un. We have discussed this. Projection of A on B, B on A. So you know C, you know projection of. That means you know Cn.
Well, wait, you can do the projection of C onto UN, but it's ultimately saying find C onto A and B.
Right. So you'll find Cn, right?
Okay.
If you look at the hint, now.
Oh.
You wanna find the projection of C into UN,
Yeah, on UN.
And
so
C is here.
You will get this.
Do the cross product of A and B divided by A times B, and then you do C dotted with that value over UN to get the projection of C on UN.
Projection of C on UN. Figure this out, how to do it.
C times the dot product of C and UN divided by UN
UN is 1. If you divide it by UN, it will still be,
divided by 1.
it will be 1. You can do divided by UN, yes.
The
But it will
projection,
be 1. Because the UN is already 1.
you said the projection of C onto UN?
Don't try to write it down, try to understand the concept. You're trying to understand the concept,
Yes.
right? You following?
How do you do this? How
Sure.
do you do it? Can you explain that again? How do you do it? C onto
He said,
C onto CN or UN?
You cannot do C onto Cn. Cn is, we don't know Cn. What do we know now? We know UN, right? So how do you take a projection of something onto something?
Dot product.
Dot product. So look up, that's the, I have sent you an email, okay? Whenever you have trouble, go back and review your assignment 1. You have to do that, you have to literally do that. If you don't do that, most of your assignments, most of you who have submitted assignments, you have just copied down stuff and given it to me.
It's still need great work.
You want me to grade? That's not going to help you. That is your foundation. You are very weak in that. Realize that. And try to develop that. Every time you go back to that foundation. Projection. If I don't know, if I say projection and you don't know projection, you go back and review what is projection. And it's clearly discussed. It's not that it's something new. It's there. And if you had done your review assignment correctly, or if you had done your review assignment honestly, you would have understood what that projection means. So if you don't understand, that's okay. You go back and review it. You'll do it, every one of you. Projection, you'll go and check out what projection is. Yes, Clayton.
If UN wasn't a unit vector, it was divided by whatever the value is.
Right, you go back and I would also, I don't want you to give answers to people, so just go back and review projection, you'll understand what I mean. Just understand, just try to review what the definition of projection is.
If you all don't understand, we'll get the full point.
Hmm?
If you all don't understand, we'll get the full point.
It's not about points. I'll give you points, I'll give full points right now, but once you go out, you have to be valued. Okay? And that is what this value. You're trying to stand out now as aerospace engineers.
Yes. And we purchase EPA.
Alright, let's go to the next one. What is the next one?
what's the relative motion?
Relative motion. Okay. So this relative motion, I think this is probably going to be, and this is something where you can really use MATLAB. If you're smart enough, if you're even decently smart, if you're an aerospace engineer, If you think you're decently smart, then you'll use MATLAB for this. Okay?
But when you submitted the homework, you want to see it work right now. Correct?
You just give me the MATLAB, attach the MATLAB code, or just attach the MATLAB output.
Oh,
Okay? Because if you try to do it with hand,
So the things that almost need MATLAB, you're not gonna give us something so narrow on a test, right? So you wouldn't give this on a test?
I may give you a simple version of that.
Yeah.
The tests are actually to test your basic foundation. It will not test your ability to do arithmetic or use calculator. Okay?
That's it.
All right. This fifth problem is a relative motion problem, right? So what you have here is we have discussed this in class. We have practically done the same example. You're very early in the course. If you are not familiar with MATLAB, try to familiarize yourself because it will help. And it will definitely help for you in the next semester when you take automatic controls.
But, you said you have MATLAB in your computer, right?
In my computer I have.
So, I think you do it better, like, once we try our own, so you can go ahead and, like, show us, like, how exactly we are.
Sure, we can do that.
Yeah, like, lifting up there.
So what you have here is, the fifth one is, but try to do it on your own. Just do some, yeah. The fifth one is relative motion, right? What you have is, we have done this, you have one inertial frame. This is cap I, cap J, cap K, okay? And then what you have a point T somewhere. You have a moving frame and then a point. So you have a moving frame. This is small I, small j. And then you have some point P. This origin is O. This is the moving frame. This is R relative, right? What is this? R O. Correct? This is R. Clear? Now what you are going to see there is R is what? Particle P. And this is absolute position. This is also equal to RP. It just means that it is the position vector of particle P. Got it? Now you see that this is coordinatized in cap ijk free. You'll see that in the textbook. R is what? So if you observe carefully, it uses small ijk and cap ijk. You have to be very, very careful with that. Okay? So this cap, for example, R relative, you can coordinatize each of these vectors in any frame. You can coordinatize this R relative in either this frame or this frame. Only the components change. The components and the bases change. Now R relative, you observe that it's coordinatized in small ijk frame. Okay? RO is coordinatized in cap ijk frame. And you see something like this. I is, you have something Ix, I plus Iy, G plus Iz, K. Okay. So this, what does this mean?
Wait, what?
You'll see this in your this thing.
It's on the
Small I is expressed in terms of cap ijk. What does that mean?
It means that,
Relative motion of I.
yeah,
It's not relative motion, but this I itself can be expressed in terms of ijk. This I will have components in ijk.
the eye of the moving frame
Right.
will have components
In
in
ijk.
all
yeah.
directions of the inertial frame.
Right. That's what it means. Okay. So similarly, J
Similarly, J and K.
J and K. Now what you're required to find, what are you required to find? VP, right? Is this what you're asked to? Is that right?
Vp, the velocity of P,
Particle P
particle P.
and acceleration.
That's on one of those, that's probably 1.13.
Absolute position.
Hmm?
Absolute position.
Acceleration.
Our acceleration.
This is acceleration.
It also says my absolute position.
This is the absolute position.
Oh.
R is the position. We always use R as for position vector, V for velocity vector, A for acceleration vector. Now this R is equal to what? R naught plus R relative.
Can you explain absolute position?
Absolute position is position with respect to an inertial field.
Okay.
Okay? So this is what it is, right? Now you are going to do what is VP? VP is, you can say this is nothing but RP. Okay? This R is nothing but the absolute position of particle P. This VP, V is similar. You just do d over dt of R naught plus R relative. Okay? What is tricky here is, one, this R relative, it's actually given to be in ijk frame. So for every ijk, you have to substitute that cap ijk.
The equation
Hmm.
that you came up with for the first one,
Hmm.
for RP, that says RP equals R vector.
It's the same thing, that's what I'm saying.
Okay, and then now that's a standard formula, but below that, what's going on there? Oh, you're just saying that goes back to the deriving that we did in class to get the omega and all that? That's what you're saying?
Now you have to be very careful. If you coordinatize this R relative in the inertial frame, okay, it will not have an angular velocity component. Omega component it will not have. Correct? If you coordinatize it in this frame, you have to take into consideration the angular velocity of this moving frame. So when you do this, right, try to take this approach. Do this. What is the derivative of this? So you're going to do you're going to use this, okay? R naught plus R relative, right? d over dt or d over dt local of this plus cap omega cross with R naught plus R relative. Okay. This is, if you do this correct, I think it'll prove to yourself that you're ready for this course.
Oh, for sure.
If you're saying, if you can do what? If you can derive.
If you can rightly, see there are two ways to do this. One is you coordinatize everything in this frame. And if you take a derivative, this component will not be there.
What component won't be there? The angular momentum?
Angular velocity. Omega is the angular velocity of the moving frame. See what happens is if you use this R relative in ijk frame, okay, what will happen? This frame will cease to exist. There is no need for that frame because everything is in this frame. You are taking the derivative in this frame. But that may be a little bit difficult to understand. So just follow what has been discussed in class. The extra hour which was done in class, we did this, right? We did relative motion. So just use the principles taught there. The only thing is, at the end, you just make sure everything is expressed in either small ijk or cap ijk. You are required to find Vp, which is the absolute velocity of the particle P. That means you have to express this Vp in cap ij. Everything has to be expressed in cap ij. Acceleration, again, everything has to be expressed in cap ij.
Why does it, one more time, why does it have to be capital?
Because it's a absolute position or absolute velocity. If you want to add them together, if you want to validate your answer, if you can do it like some of it could be in I, some of could be in cap and small ij, but you will not be able to verify your answer. If you want to verify, just do this. Go through the relative motion, this thing which was discussed in the next hour, and at the end try to substitute ijk, small ijk, the definition of small ijk, or the coordinatization of small ijk in cap ijk. Okay. Try to do this. This is a very interesting problem. What is the next one? Last one is
Number 6 is the one about the cases.
okay. Number 6 is actually fairly simple. Like we have discussed this in class. So you have two vectors. You have to just reapply this concept. Number 6. Coplanar. So if you want to See, we have vector A, B, C, right? A, B, C, A. These are coplanar. How do you validate coplanar?
Get cross product of the
Isn't it the triple product equaling zero?
Why is that the case? Which triple product? Scalar triple product, vector triple product?
Vector triple, scalar.
Why scalar triple product?
I don't know why, but I saw it as a rule, so.
So that is what you need to understand. If you just think about this, see, we actually discussed this, right? So this should give you some idea. The dot product of perpendicular vectors. I'll tell you. So see, if you take A and B, if you take the cross of A and B, what are you going to get? You're going to get some vector in this UN direction. If you take dot product of this and this, what is going to happen?
Dot product of U and A.
Yeah,
EAB. Oh yeah, zero.
it's be 0, right? Why? It's perpendicular. If you take the dot product of this and this, what happens?
Zero.
Right? So if these three have to be in the same plane, dot of this and this has to be 0. Now you understand? So you have to combine those two. So think about this. Last one is, alright, the last one is actually a little bit unique, just a starter. What is it? You have U, you have three vectors, right? What is it? UN, UT, and UB. And what is the relationship? U?
UNT or UT and UT are perpendicular.
Right. And what is the relationship between cross product?
UT cross UN is equal to UB.
Cross UN is UB, right? Alright. What do you need to prove?
The paper says use the backpack rule to show that UB cross UT is equal to UN, and then UN cross UB is equal to UT.
So you have to show. Alright, this is given, right? We'll start with given. Okay? You have UT crossed with UN is equal to UB, right? You need to show that UB crossed with UP is equal to UN. Okay? Now just look at this.
You forgot the little hat over the UT.
That lost
So just look at this. Look at this. What would you do? How do you go about
TST?
huh?
TST is that?
To show that? This is what we need to prove. Okay? So look at these two. See, this is where you really need to think. This is how you approach problem. And this is very simple. How do you start? So look at these these two and tell me how many is not.
So you want to show that those are the same thing? Is that what you're saying?
No, you need to show this.
So that.
This is, you need to show this, but you know this. From knowing this, how do you go to show this?
So we take like one product and then substitute.
Triple product?
Uh,
Where is triple product? Huh?
We can make these a lot.
Yeah, you can make triple product. So how do you make the triple product?
that's backcast.
Just multiply like
Backcast.
You gotta get to the triple product first.
so in the UB we just substitute those values like UT cross UN at the where UB comes second.
You want to substitute this here?
No, that here.
Hmm?
That to the UB.
What if you divide?
Just so you will substitute the left hand side of the first
You
UB. UB will substitute with that one.
with this one.
Yeah.
But we don't know that yet, so we can't just like put it in.
Okay, so you agree with this. Now see if you can make sense. It's the same thing, right?
Oh, so you substitute in U cross B, U cross T for U cross N into the given equation.
What do?
You substitute in the U cross B.
Do you substitute or what do you do?
And make that equal to UN.
You take cross with cross on both sides with U T
Take cross
post cross
cross what? Post
with U T. What does post cross and pre cross mean? The order matters. A cross B is not B
Oh,
cross A.
so post cross means like a cross after. Okay.
Right. So what you get is UT crossed with
You cross at the last.
UN crossed with UT is equal to UB cross UT.
Where did UT come from? The second UT.
Huh?
That's what we're crossing both sides.
You cannot cross one side, right?
Okay.
Because then you're changing, it is not, you're changing the equality or inequality. You have to do it both sides to maintain that equality. If I do this, then this will be not equal.
So,
Right?
but so you didn't do anything with this UN equals UB
Huh?
cross UT under.
Something seems like it's missing. You have UT
Huh?
cross UN.
Right. So this is that UT crossed UN. I crossed this with UT.
And how did you know how did you know to use that particular one UT?
So that's what I was trying to tell you guys. Look at this and look at this.
That's
We want to use
Oh, and that'll be UB.
Huh?
So when you have UB.
What will this be?
Equals UB cross UT.
What do you have to prove here?
That's
This?
UB.
Huh?
That's UB.
UB.
Yeah, you have at the top given UT cross UN equals UB, and then you have down there UT cross UN, so you can't put in
Oh.
UB. For,
UB here.
yeah.
I looked at the two that you said look at, but
Oh, it's
Yeah, if you put UB, you prove that UB cross UB equal to UB cross UT. What are you proving? What are you asked to prove?
UN. That left side should be UN anyway.
So this thing, you have to prove that this is.
UN.
I still don't see why we use UT.
Huh?
Because we need the UT with UB.
So that's what, when I say look at this. Look at this.
Oh.
UT cross UN.
Look at this.
Where's the
No,
Did we substitute?
no, you just like you have to.
Look at this. Look at this and look at this. Guys, pay attention here. Look at this and look at this. Why do we cross UT? Look at the left hand side, look at the right hand side.
It's still equal. It's still equal.
What?
Cross UT to both sides.
Oh, is that what Roger just said? Can you say that again?
Because if you
No,
divide it,
she
it's still one.
What do you want? What do you want on the right hand side?
Right.
Okay.
With UP wants UT.
What do you have on the right hand side?
Okay.
Yeah, okay.
So all you have to left is you have to prove that this is UN.
Wait,
Can you prove this is UN?
Yeah.
How do you prove this is UN? What do you do for that?
So what are we trying to prove exactly?
The left hand side and again.
The part you just added in?
Huh?
So not the first line, what you prove?
This is known, Clayton.
I'm talking about on the right side.
This is what you need to prove.
So are we trying to prove both of those?
This and this is the same.
It's just like
Oh, yeah.
it's in the.
This and this. I just changed the sign.
Yeah.
See, I tried to show you this and this in this form.
Where's the sign change?
You couldn't do it. I just change the
You went on the right
Yeah,
side.
that would be-
So that's the reason I changed it to left hand side, right hand side, right hand side, left hand side.
That's
So what's the you want that line down? You're saying UN is equal to what? The whole underlying line?
That's what you need to prove.
No, I'm at.
Huh?
No.
This whole underline is equal to UN. That is what you need to prove.
It's still not even, you need to prove that.
Oh yeah.
So how are you going to prove that?
The formula.
What for? Huh?
Have that.
Back minus cab rule. That is what it says in your assignment.
Back tab.
Use the back cab rule. So this is where you use the back cab rule. Can you use the back cab rule on this one?
No.
So you have to get into a state where you can use the back cab rule. Okay. Now you have to be very, very careful with something here. When you do this cross, right? So we did a cross with UT, right? When I said take post cross, there was a reason this was. You cannot do this. The bracket has to be for this. This is different from this. You understand? It's not the same thing. So when you put your brackets, make sure you know where that bracket is. Because see, this is some other vector, this is some other vector. It changes the whole arrangement. So you have to make sure that bracket is maintained. Now you know back cab rule. In what form do you know back cab rule? You know A cross B cross C, right? So you compare this, what do you do? It's not in that form, what do you do? It's not in this form.
Can't you bring the
Well,
other
take
one
that
and
as
change the sign?
Huh?
Reject whatever she in the.
This is, so what do you do? This is what you know, but this is not in that form. What do you do?
Bring it to the other side and change the sign?
No.
That's good. So you have, this is what you have, B cross C cross A, okay? But you need it in this form. Got it? So you just bring that to that side and change the sign. A cross B is minus B cross A. Okay? And you have to, if you apply now you have to apply the back cab rule to be very careful. This and keep the negative sign outside when you apply the back cab, and then finally apply the back cab. Okay? I think that should be it for today.